Hi everyone, in this lesson we're having a look at differentiation from first principles. So let's start out by looking at some curve on the xy axis. Okay, so we have the x and y axis, and let's say we have some negative parabola. Differentiation is the process which will allow us to find the gradient at each individual value of x on the curve here. And the gradient will be represented by the tangent at that point. So that green tangent line would represent the gradient at that point there on the curve, the green point. In the past, we've been looking at gradients and straight lines, and the gradients are constant on a straight line. But for curves, the gradients can be different at all different values of x on the curve. And to find the gradient at each individual value of x on the curve, that process is known as differentiation. And that's what we're going to have a look at now. And this is based upon the gradient formula, rise over run. And we are working this out, we're calculating it for x. First value of x is x, and the next one is x plus h. So our value of x plus a little bit. And we're going to take the limit as h approaches 0. So the limit is these 2 points, so it could be this point here and this point here for that value of x. The limit is those 2 points get infinitely close together. That will give us our gradient function, our derivative. So let's have a go at calculating a derivative. Okay, so let's say we have y is equal to x squared. Now to find the derivative, the first derivative, it can be denoted y dash or dy dx. We are going to take the limit as h approaches 0 of function x plus h, so the value of y at x plus h, minus function x, so that will give us our rise, over the run, which will be x plus h minus x, so it's just going to be h there on the denominator. So let's go about calculating this. So the limit as h approaches 0, function x plus h will be x plus h squared, because our function we're working with here is x squared, minus our function, which is x squared, and this is all over h. And we can note that we can't just substitute in h equals 0, because then we'll get a 0 in the denominator. But if we clean up the numerator, if we have a look at the numerator, we'll have x squared plus 2xh plus h squared minus x squared, and they will cancel out. So this will be our numerator. So we'll just get rid of that and put a new numerator on. So it'll be 2xh plus h squared. That's our numerator. Okay, so now if we factor out a h and cancel it down, we'll just have a 1 on the denominator. So we end up with the limit as h approaches 0 for 2x plus h. We don't have to worry about the 1 in the denominator. And now we can substitute in h equals 0. So that will just become 0, and this whole thing will equal 2x. So our derivative, our first derivative, this thing here, is equal to 2x. So this will tell us the gradient at different points on the curve, different values of x. So if you want to know the gradient when x equals 1, you'd substitute in 1 to this. So this is equal to 2x. So if you want to know the gradient when x equals 1, you just substitute 1 in. And if you want to know the gradient when x equals negative 10, you'd substitute in negative 10 and you'd get the gradient's negative 20. So this process of differentiating will give us this first derivative here. And we can, with our derivative, with our gradient function, we can find the value of the gradients on different points of the curve. So that's the whole idea with differentiating. We will differentiate it, and we'll be able to say what the gradient is at different points on the curve.